morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Tubinta with another video. Alright, so we are continuing on calculus. This is differentiation. The second differential coefficient, which is d2y dx2. And then we have these two practice questions right here, and then practice question 2 has its own sub questions. So let's get on with the answering of this video. Alright, so if you look at the question, it reads, if y is equal to 1 divided by 2 minus x, find dy dx squared and the 2y dx2. And then the second part of the question says, show that y times the 2y dx2 is equal to 2 times dy dx squared. So this is just something that is applicable to this function only, not all functions. It's only applicable to that function. Okay. So the answering will go like this. We'll say y is equal to, okay, we have this particular function, but we're going to write it in this form, 2 minus x raised to the power negative 1. So I've taken the 2 minus x up, and then the two terms, the 2 and the negative x there, they're going to be in a bracket, and then we're going to raise it to the power negative 1. And then they're saying we need to find dy dx squared and 2y dx2. So to find the derivative, we are going to say, you can use the chain rule, alright? While you say let u be equal to what is in the bracket here. So I'm not going to use a chain rule, I'm going to use a different method, which is dy x is going to be equal to the derivative of this particular function is negative 1 multiplied by 2 minus x, then negative 1 minus 1 is to the power negative 2, and then you multiply this by the derivative of the core. The core here, there is 2 minus x. The derivative here of negative x is going to be negative 1. And then to continue, you can see that here there is a negative 1. Here there is a negative 1. So if you can see that there are numbers like this, you multiply them. Hence, your dy dx is going to be equal to 1. You divide by 2 minus x raised to the power 2. So you write it like that, this and this will give you positive 1, then you divide by this because we want to leave this power positive. So therefore we take it down as a denominator like that. So that's your dy dx. Now they want us to find our dy dx squared. Okay, our dy dx, okay, it's still our dy dx, but it has to be squared, will be equal to 1 you divide by 2 minus x squared, okay, so that has to be squared, and then again we have to square it. Okay, so how do you proceed from there? What you do is, first of all, you square 1 squared will be what? 1 times, it means 1 times 1, which is 1. Okay, and then here we are going to apply the laws of indices. Index of an index. For example, if you have 5 squared the power 2, we say index of an index. We multiply these two powers, it will be equal to 5 to the power 4. So we're going to use that same property in this particular question. So index of an index, here there is 2 minus x, which has to be squared. So index of an index will be 2 minus x the power 4, because 2 times 2, not 2 to the power 2, but 2 times 2 is 4. And here I did not say 2 to the power 2 when I wrote it like this. No, I'm simply multiplying. So even if it was a 3 here, it would have been 2 times 3, giving you the same as 5. 5 to the power 6 will give you the same result if you are to simplify this. Okay? That's what you need to know. You multiply the numbers, not 2 to the power 3. You multiply the powers. The powers that you can see there. That's how you simplify the index of an index. So our dy dx squared will be equal to this answer here. 1 you divide by 2 minus x raised to the power 4. Okay, so after finding that, we are almost done. Okay, we can clean up the top. Now we need to find our second derivative. So this is our first answer there. Then they said find our d2y dx2. Okay, so d2y dx2, that's how you pronounce it. It will be equal to, you differentiate the first derivative. So this is what you found as your dy dx, right? So to find your d2y dx2, you differentiate your dy dx. So if you differentiate this, you can't easily differentiate it the way it's looking, or you can get confused. So it's better you write it like this. Raise the power -2. Have you seen what I've done? So after doing that, I can clean up. So we will say d2y dx2 is equal to -2 multiplied by 2 minus x raised to the power -3 multiplied by -1. So this -2 we multiply by -1 is going to give you a +2. Okay, so let's clean up. So our d2y dx2 is going to be equal to a +2. We divide by 2 minus x raised to the power +3, like that. So alright, let's skip that. So raised to the power 3, like this is your d2y dx2. Alright, so we have found our d2y dx2, and this is our dy dx squared. Let me write so that you can see. So this is the answer for that. Then dy dx, which has to be squared. That's the answer that we are getting. And then they said that y dy dx, y d2y dx2 is equal to 2 multiplied by dy dx squared. So let us clean up and write what they have said. They are saying that y multiplied by d2y dx2 is equal to 2 multiplied by dy dx, which has to be squared. So our y is this function here. This is our 1, you divide by 2 minus x multiplied by our d2y dx2, which is 2, you divide by 2 minus x, alright? 2 minus x, I hope you can see that, raised to the power 3 is equal to 2 multiplied by dy dx squared. Dy dx squared, the answer that we found is here, which is 1 divided by 2 minus x raised 2 minus x raised to the power 4, like that. So this statement simply means we write it like this. Okay, so we have answered the first part of the question. We answer in the second part of the question. Okay, so to proceed here, I want you to think of a law of indices. Okay, so for example, you have b to the power 1 multiplied by b to the power 3. When you're multiplying numbers, let me say numbers. So think of b like a number, okay? Or let me just say even just a letter, okay? You're multiplying something which has the same base, like that. What you do is you need to add the powers. When you're multiplying, you add, okay? When you're dividing, you subtract. But in this case, we are multiplying. So b to the power 1, so even b to the power 1 is just the same as b. You don't need to write the power 1. So b multiplied by b to the power 3, you're going to have b to the power 1 plus 3, which is going to give you b to the power 4. So I want us to think in that way to simplify what we have there on top. Okay, so if we clean up, we are going to say 2 times 1. So we're going to multiply the numerators, okay, and the denominators. 2 times 1 is going to be 2. You divide by. Here, as you can see, there is 2 minus x. And then here there is 2 minus x raised to the power 3. So sometimes you can even have an expression. This is an expression. 2 minus x is an expression. And then it is being raised to the power 1. You can't see that 1, that's why we don't even write it, because it's an invisible 1. So 2 minus x to the power 1 times 2 minus x to the power 3, you're going to get 2 minus x raised to the power 4. And you add the indices, which is equal to 2 multiplied by the numerator will be 2, you divide by 2 minus x raised to the power 4. And then the question said, show that the 2y dx, y multiplied by the 2y dx2 is equal to 2 multiplied by y dx squared. So you say that is equal to that as a conclusion, hence shown. Always remember to write the hence shown. Alright, so if you really look at the question and evaluate it the way it's looking, this is your final answer. Thank you so much for watching this video. This has been Cornelius Binda, another video, and bye bye.